Exercise 6.1 Problem 8 Discussion. In the figure, DE is parallel to AB and DF is parallel to AC. Prove that EF is parallel to BC. So let's look at the figure. Oh, it's complicated, isn't it? But anyway, don't worry, we'll break it into smaller parts and we'll be able to do it. DE is parallel to AB. So that is DE is parallel to AB. So which means you can apply Thales theorem for this triangle, that is PB, or that is PAB. For the triangle PAB, you can apply Thales theorem. Then DF is parallel to AC, right? So which means you can apply Thales theorem for PA and C. Then it's asking us to prove EF is parallel to BC. So again we'll have to find ways to apply converse Thales theorem for this triangle PBC. Okay, so have this in mind and let's get started. So we are given the conditions that D is parallel to AB and DF is parallel to AC. We need to show EF is parallel to BC. The formula is Thales theorem and the converse Thales theorem will be applied here. Step 1. Review the given figure and identify the triangles for applying Thales theorem. That's what we did, no? Right. So since this line is parallel to this line, so this triangle you can apply Thales theorem. Similarly, this line is parallel to this line, so you can apply Thales theorem for this triangle. Right? Next, apply Thales theorem for PAB. When you apply PAB, what will you get? PD by DA will be equal to PE by EB. That's what they've written here. Next, apply Thales theorem for PAC triangle. So which means PD by DA will be equal to PF by FC. That's what is given here. But if you look at equation 1 and equation 2, the LHS is the same in both cases, which means the RHS also will be the same, right? Which means PE by EB will be equal to PF by FC. Now carefully look at it. PE by EB equal to PF by FC. What does it mean? By converse Thales theorem, EF is parallel to BC. And that's what we want to prove. You got it? So this is the way the problem needs to be solved. So I've almost done the problem here. So please pause the video and do the problem on your own. And on completion, please come back and check your working against our solution. The solution, right? So it's given DE is parallel to AB and DF is parallel to AC. So let's take this condition of DE is parallel to AB. DE is parallel to AB, right? And applying Thales theorem for PAB, you will get PD by DA will be equal to PE by EB, right? Similarly, applying DF is parallel to AC is given here. So applying Thales theorem for PAC, you will get PD by DA will be equal to PF by FC. It's given. And you can see the LHS of equation 1 and 2 are same, so which means RHS will be the same. So PE by EB will be equal to PF by FC. Now you look at this, PE by EB equal to PF by FC. So by applying converse of Thales theorem, we know EF is parallel to BC. So by applying converse Thales theorem to triangle PBC, we get EF is parallel to BC. I'm sorry, it is not QR, it is BC. Okay. Since I've taken this from the previous problem, I missed to change this. Okay. So EF is parallel to BC. Okay. So I hope I made it clear. If not, please go through this video one more time. It will become very clear. Okay. Thanks for watching this video.